Hello. You are new, right? What's the name again? Oh, this where you from again? Where's- Okay, please turn to this page number 5. Okay, question number 3. Okay, in this question, you have to. Okay, let's read the question together. Okay, I think you have learned before. This is the lens. Lens. So there are two types of lens. This is the thin lens. Is a convex lens. So convex lens is a converging lens. Okay, have you learned this before? Learned before. Okay. So step number 1 is you have to draw a line from here parallel to the principal axis until you meet this point. Okay. So this is the one. Okay, draw one line. Okay, and then this line, after that, the same line will be converging to the focal point. Okay, that means we have to draw another line from this point to the focal point. This is called the focal point. Okay, so first line and the second line. Okay, draw an arrow. Okay, another one is you have to draw from the tip again to the this point. Okay, central. Okay, optical center until they meet at a point. Okay, so these two lines will be intersecting at this point. Okay, so this one will tell us the position of the focal point. Okay, no, focal point is here. This is the position of the image. This is the image falling down. Okay, so from here you draw another arrow, and this is the image. Okay. 哎，你的朋友。啊，OK。Okay, use this to determine the focal length. Okay, actually we haven't drawn this one yet. By right, we need to okay, we need to measure the length of the focal length. So what is focal length? So can you see there's a focal point here, and then there's a optical center. So what you need to do is you have to measure the distance from here to here. Okay, so you have to base on the grid line. This one, every one grid represent 0.5. So can you count and see how many grid lines are there from here to here? How many are there? 一共几个? How many are there? 这个. Is it 10? Okay, 10. If this is 10, so the focal length because every grid line represents 0.5, so you need to take 0.5, 10 times 0.5. So how many cm? Okay, so this is the 5 cm. 5 cm is the answer. Okay, just 5 cm. Any question? No question. Okay, on this one, draw a ray from the tip of the object that passes through the principal focal point and to the lens and beyond it. Okay, so what you need to do is tip. Okay, it means what you need to draw is you need to start from the tip to this focal point. This is the first focal point, and then you have to make it passes through and then come to this point. Okay, then after that you have to start from this point and draw another parallel line parallel to the principal axis. So you find that all the three will be meeting at the same point. 三个都是会撞在一起的。Can you see that they are meeting together at the same point? This line and this line. So more normally when you draw this is called ray diagram. So for this ray diagram, we can see that you can form three lines. First one is the one parallel to the principal axis, and you convert to the focal point. Second one, when it passes through the optical center, then it will not be any deviation. 这个自治区也没有变方向了 ，to be straight. The other one, when it passes through the focal point, after passes through the lens, and the ray become parallel. Okay, so all these three will be meet at the same point. Okay, 做完了你，全部做完了。Okay. Okay, so okay. So this answer. Any problem? No problem. Okay. This just me. Okay. Done. All this one you learn in school already, right? Or finish already. The light ray diagram thing. Not yet. But you learn, you know the basic. Yeah. 坐哪里？坐这边。Okay. Okay. Let's continue. So 这个上礼拜你在吗？上礼拜没有来，有来。Okay. Next question, you have to draw an arrow to show the position and nature. So we can see that the image is formed here, and we will compare the size. What can we say about the size? Are they the same size, or enlarge, or diminish? Diminish. They are. That means the image becomes smaller. When the image becomes smaller, we say diminish. Nature of the object. So first, you have to say is diminish. That means become smaller. The image is becoming smaller. And normally, when you talk about diminish, you also have to talk about inverted. So what's the meaning of inverted? Means upside down. It's pointing down. And the last one, you have to talk whether it's virtual or real. So this is virtual or real. This is called real. Why real? Because what can we see for the object image? Where is object? Object on the left hand side. Where is image? On the right hand side. Are they in the opposite side? Yeah, one on left, one on right. So when it's forming on the different side, most likely it's a real image, real one. Okay. And then somehow you have to talk about whether it's formed by real ray or dotted ray, because there is a possibility that the ray can be virtual. Okay, so this is formed by real ray. So these three, do you understand? So these three, diminish, inverted, 倒反的意思啊 inverted. Okay, real, 真实的 virtual means not real. Okay, virtual ray. Any problem? No problem. Okay, next one. The lens form array to tell the position of the ray. Okay, so I think you should know there are three types of ray. Normally, this is the first ray. And what will happen when you draw the second ray? Second ray will be the ray that passes through the optical center. When the ray passes through optical center, it will not change direction. So what you need to do is you need to draw from here to this point, and then you just continue drawing until intersect. Okay, so this is the second ray. So 它没有改变方向，自持器的。Okay, it will not change direction when you draw it. So can you see that they are meeting at this point? They meet at this point. 这个点呢 Okay, so you'll be able to see this is the position to locate the arrow to label it as I. Okay, so after you have done so, you need to draw an arrow, and then this is falling down. Okay, so this is, you have to label this OX. Okay, arrow to, this is the X. Okay, label this one as I. So you have to name this one as I. This is the I. Okay, mark the principal focus and on the lens and label this one as F. So where is the principal focus? Do you know the precision of principal focus? Where is it? The point is actually here. This is called principal focus. Okay, this is the principal focus. And measure and record the focal length of the lens. Where is the focal length? Focal length is always from this optical center to this point. Can you measure the length from here to here again? Okay, please try to measure. Try to measure and see. Okay, so this is done. How long is it? What is the length of this line? 温气啊，温气是多少？ What is the length? 2.05. Do all of you get the same thing? 2.05. You can read until 0.05. Okay. 2.05. Okay. Normally you can. It's difficult to read until 0.05. 2.0 will do. Okay, 2.0就好了，2.0 2.0. Okay, this is the 2.0 until here. Okay, done already. 2.0. Okay, good. I describe the image. So what can we see here? Is it larger? are they the same size or smaller? Compare the length. What can we say about the length? Are they same size or smaller? 小过一点还是大过一点？啊，周志威，这个比较长，这个比较长。Okay, so it's shorter a bit. Okay, so shorter is diminished. Inverted or upright? What do you call this? Going down, it should be inverted. Okay, inverted. So tick on inverted. Inverted. Any problem? So just compare the size and see the arrow. If size smaller, it's called diminished. If the arrow is pointing down, it's called inverted. That's all. Okay? Inverted and diminished. Okay, can you turn to this page number 11? 11. Just one. Okay, hey, I think today we have discussed other question, but not this one. Right? Okay, let's go to this page number 11. Okay, so this page number 11, there is a similar graph. So the path locate the image of whole of the lens. Okay. So do you know what to do? Okay. 这个上个礼拜我们你有来吗？上个礼拜？哎，就上个礼拜没有来吗？哦，OK OK。Okay. This one, this one. How to find the O? Okay. So what you need to do is we can see there are two rays here. So you need to draw an arrow to find the image and I. So first, when this is parallel, then you should know the ray will be going down and pass through the focal point. What will happen to second ray? When it's passes through the optical center, it will, what happen? It will be in the straight line. Right? It means it doesn't change the direction. So what you need to do is you just have to extend this line until they meet at a point. Okay, until they meet. So we need to find the image. So where is the image? Okay, the image will be formed on this point. So where is this point? After that, you have to draw an any problem. 明白吗？这个 Okay, it means draw a line. First line pass through the F, second line passes through the optical center, and then when they meet, you have to draw an other line point to this point like that, and then you have to call this point I. This is a arrow I. Okay, so this is the I. Okay. 哎，你做完了在那边玩电话，笑啊你啊！你好像你的朋友也看住你在玩。 Ah, that one. Okay, this is I. Can? Okay, so arrow O. Okay, that's all. Any problem? No problem. Very easy. Okay. Okay. Question two. The lens, the image I, and then we need to find the O. So how do you find? Okay. So um, how to draw? Okay. First one that is we need to join from here and then go backward, right? Go backward. Okay, go backward. Okay, A and B is a focal point. And then you need to draw a parallel line. Parallel. Okay, after that, what should you do? We need to draw another line. We know they'll meet at the same point. It means if you draw like that, you can find another line, right? Okay, so when you draw something like this, then the intersecting point will be the object. Correct or not? Okay, so the ray supposed to be coming here, going down, then meet like that. So this is the object. Okay, object. Okay, so in the exam, sometimes they will give you object, ask you to draw image. Can also be giving you the image, and then you need to form the object, go backwards. So it means the light ray can be reversed. Okay, 倒反. Okay, you can go backwards. Sometimes forward, sometimes backward. Any problem? Okay. Okay. Uh, so where is the focal length? I think you should know which part is equal to the focal length of the lens. So focal length, this point to this point is called focal length, right? This point to this point is also called focal length. Bring the one that equal to the focal length. Okay, so no other answer, right? So this is the first focal length, and this is another focal length. Okay or not? Any problem? Online one, any problem or not? Tina, okay or not, Tina? Anything that you want to ask or not? No question. Fatima?
No.
No, too easy. Nothing to ask. Okay, good. Okay, the next one. Okay, try the next one. Okay, next one is about the green light. So this is the green color light. Triangular glass block, light red line entering the same path. Draw the red light. So it's telling us that the red color one also passes through the same, but this one the red color spectrum of color Roy G Beef. Okay, so red color has the longest wavelength. So when we compare the wavelength, do you know what is wavelength? Wavelength. So this one has the longest wavelength, lambda. Okay. So this one has shorter. Okay. So this one is similar to the one on the rainbow. So you just need to know who is above. What color on the top? Which color we see first? Color, the top layer is what color? Red or blue? Indigo. It's a red one, right? The last one is the indigo, right? So the green is in between, right? So that means this one, the red color should be above it. So it should be here. Okay, maybe like that. Okay. So just need to draw the red color ray. This is for red, and this is for green. Okay, slightly above. Okay, because the different color have different speed in the prism. So this is the normal line. So which one is slower? You see this is the rate of refraction is different. Okay, it's different. That means we can see the green color line is closer to the normal line. Closer. So when it's closer to normal line, what does it mean? Slower or faster? Slower. Closer to this line. When it's away from this line, it's going to be faster. Further one faster. Okay? So they have different speed. The speed will change. Okay, same path. Okay, this one we know already, no problem. Very easy. Okay. Draw the path for the red color. Okay. So how do we draw? Okay, this is the rectangular glass block. So this is the normal line. Normal line is a 190-degree. You need to have this line. So there'll be another line. This is normal line, 90-degree line. So we need to draw the red color line again. This is green. So what happened to the red color line? Above this line or below this line? Above or below? Above, correct. So we need to draw another line above the line. So above the line means like that. Okay. And then on this point, you need to draw another normal line. When it's coming out, it should go back to the same direction. That means you'll be parallel to this line. That means when you go in, you bend slightly towards a normal line. When it's leaving the block, you'll be back to the parallel line. That means you'll be parallel to this. You'll be parallel to this, because it's 同心. So that means you need to draw another line and make it go back to the parallel line. Do you understand? It means coming in slightly above the green line. When it's coming out, the light should be back to the same direction. Okay? Same direction. Any problem? No problem. Okay, this one okay. Just one. Okay, next question. Okay, this one also there are two speed of light in the air. This is the refractive index n. So for this one, there's a formula for refractive index. N equal to C over V. So this is called refractive index. This C is speed of the light in the air. This is in air. And the other one is the speed of light in the water. Okay, one for air, one for water. So what you need to do is to do the calculation. We are looking for speed of water. So we have 1.33 is equal to the speed of the light in the air and divided by speed of the light in the water. Can you try to get the value? What is the value? You have to take this number divided by 1.33. Okay, what is the final value? It's wrong. Okay, try to calculate and see. I'll go and print the next copy. Okay, 3 to the power 8 divided by 1.33. The answer is about 2.3 times 10 to the power 8 meter per second. Okay, can you get the same thing? Okay, good. Okay, next slide. This one is parallel wave incident on this plastic and then draw the reflecting ray. Okay, do you know what to draw? So first step is you have to extend this line until they meet on this one. Extend this one first. Okay. So after that, you have to draw another line, normal line. So the normal line you have to base on this point. Draw that. Dot, dot, dot. Okay, this is the normal line. Okay, after that, you have to see how the thing will bend. You need to see this angle. This is I. When you go into the plastic, the wave will become slower. Will be some slower, you'll be reflected towards normal. It means the ray will be closer to. You have to see the arrow first. Arrow. Okay. So after it become closer, can you see that the angle is smaller? Okay. So you need to base on this. For example, on this ray, you need to draw a line from here and make it 90 degree to the existing line. It means it's 90 degree to this line. Can you see this is 90 degree? 90 degree. And then you need to use this to parallel to this ray. Okay. And then you draw another one. It's parallel to the ray again. Okay. Okay. And then you draw this again. 什么事情？ 怎么啊？画对吗？画对就好。Okay, and then the last one, from this one, draw another one more. They must be parallel to one another. And then you have to just erase this one, okay? Because it need to be same distance, okay? So all these ones should have been having the same wavelength. Here to here must be the same. The wavelength is the same. So before in the air is longer. When you come into the plastic, it becomes shorter. Okay? Any problem? Okay, the wavelength will become shorter. When in the plastic, reflected towards a normal line, then the wavelength decreases. So this is the main thing that you need to know when you draw. So reflected towards normal. Okay, then you go this way. Draw 4. So this 4, you need to use this 4 to draw. 1, 2, 3, 4. Exactly. It must be extending from here. Okay? Yeah, yeah. Draw the direction of the travel of the reflected wave. So this reflected wave is talking about this direction. This is the direction of the reflected wave. Okay, this is the one. Label the angle of R. So do you know where the R is? R is here. This is the R. Okay, so this is the angle of refraction. And this is called the angle of incidence. Angle of incidence, angle of refraction. So there are two. Okay, so what we want is actually this line, this one. Okay, okay, next one. The mirror, periscope. The periscope is used to view the gover over the head of the people. So you are here. You are just a small boy. You are not tall enough to see people play golf. So you design something like this. So how do you make? So you have to see this reflection. On this diagram, continue the ray from the golfer to the upper layer and label the normal. And we strike the mirror. So when you go in this direction, you have to extend the line until they meet here. After the meet here, this is a plane mirror. Then there is a normal line. So the normal line will be something like this, the normal line. Okay, this is the normal line. And this angle will be the same with this angle. So after that, it will be reflected to this direction. And then you enter your eye. So you can see the golfer now. Okay, so the ray will be moving on this point and then reflected by the mirror normal. Okay, there is another normal line here. This is another normal line. So this one will be going in by 45, reflected by 45, come here by 45, entering also 45. Any question? Okay, okay, very simple. Continue until you leave on the periscope. Okay, state the law of reflection. What is the law of reflection? What can we say about these two angles? For law of reflection, the I must be equal to R. That means, what it is? Angle of incident must be equal to the angle of reflection. Can you write it down? This is the law of reflection. Angle of incidence is equal to angle of incidence. Incidence. That means incoming. This is the reflection outgoing. Incidence equal to the reflection. Any problem? No problem. Okay, the next one, red color ray. S is the less than critical angle. Y is equal to critical angle greater than this. So it's talking about same type of ray. All these one are red color ray. All these are red. But the angle is different. Okay. So I think you should know the name of this phenomenon. Do you know the name of this phenomenon? What do you call this? Name of this phenomenon is called what? TIR. What is TIR? Total internal reflection. How does this thing occur? What is the condition for this? What are the conditions? There are two conditions. The ray must be travel from where to where? Light travel from where to where? Light travel from denser to less than medium. Okay, where is ray now? Are they in the glass block? Is glass block denser than air? Who is denser now? Is a glass denser than this or not? Density. This one should be higher, right? Higher than this. So this one fulfill the first requirement. Second one, you have to talk about the second one is I must be more than what? C. What is C? Critical angle. So that's why there are three situations here. Less than critical angle, equal to critical angle, and more than critical angle. If it's less than, that means the light will be able to come out. So it will come out. That means you need to draw something and make it come out. So it'll be coming out. Okay, you'll be able to come out. Okay, you'll be able to come out like that. Okay, coming out. So we can see the angle. So the angle, when it's coming out, the angle become larger. Okay, we say reflected away from normal. Why is it reflected away from normal? When because in the glass, the speed is slower. Inside the glass is slower. When it come out, it become very happy because density is less, so it can move faster. Okay, so it's reflected. The second one, when this thing is same, that means it will be along where? It will be here. Because you need to understand, when incident angle equal to C, the angle of reflection will be equal to 90. So this is a 90 degree. Okay, is equal to 90. When this one, they already tell you the Y is equal to C. When the incident angle equal to critical angle, the ray will be refracted along the interface between the air and the glass block. Interface means in between the two, 两个之间，在 boundary. Okay, what will happen when it's more than that? When it's more than that, then you'll be totally reflected. That means you'll be like that, totally reflected. When it's totally reflected, it's no longer a refraction. It become no more reflection. It's called, is this one, no refraction. It will become reflection only. That means the air is trapped inside. It can no longer come out. It cannot come out at all. It will be stay inside. Okay. Can you see the difference between them? When the angle is small, the light is able to escape from the glass. That means being reflected. When it's equal, you'll be moving along this line. When it's more than that, you'll be totally reflected. Okay? This is very important because this is the fundamental for fiber optic. So if they do not discover this, you do not have internet today. Your Unify cannot work at all. Okay? So now they are trying to raise the speed. So now is how much already? What is the highest speed? Can go for terabyte. 最快是多少？你知道是多少？ What is the speed? Normally people use 300. Slightly rich, you are rich, a lot of money, no money to spend, then you upgrade to 500. Then you still not satisfied, then you can go for 1 gigabyte a second. Okay, man, BGB. But you're not going to see the difference, very little difference. So no point. Okay, can you try to, I'll give you some time, 3 minutes to do this one. Try to complete the diagram, prism. Okay, try and see. Any problem? Put a hand. Okay. 你直接叫我来。没，先到哪里？微还没进，进不光是到这个来，对，稍微些，稍微上。诶，如果说稍微卑微些一点，稍微。但是微，好，对，好来去，微好的，不要跟你做，接着做，多那个，说这个事。知道啊，更不会做这个，没错，就因为我们的脑子是广大，多大，进有多大，有头发的是吧？太有了，估计。 Okay, let's see the answer. So this is prism. Prism and mirror is different. Mirror is mirror. Prism is prism. So, but the way the light go in is the same. Because when the light go in here, it can enter. Okay. So, but because of the total internal reflection, because it's prism, then you'll be having total internal reflection. That means it will be similar like the the mirror. It means when you come in, okay, let me just draw. This one very difficult to. Okay, that means when you go in, then there is another 90-degree normal line. Okay, when you go in, then it will be coming down. So you'll be from here, you come here, then you bounce off the second surface. Okay, then the ray will be coming into here. Okay, so we can see that the mirror and the prism having the same thing, but the concept is different because this is prism. It's having total internal reflection because of the critical angle. So you need to draw the normal line. Okay, so this angle will be same with this angle, and this angle will be same with this angle. Okay, then the ray will be coming in and enter the eye. Okay, any problem? No problem. So you just have to remember it's like that. Like go here, come in, come out again. Okay. Yeah. Okay. The ray and how it form. Okay, finish already. Show that the refractive index of this critical angle is this number. So this one is the value of the C. This is the C. This is the C value. Refractive index, there is a first formula is this one. Psi R equal to psi R. Second formula is 1 over psi C. And the third formula is C over V. So this one, you're given the critical angle and you need to show this value. Show. So means you need to use the second formula. So N 1 over psi C. So this critical angle is 45. What is 1 over sine 45? You press calculator. Can you get the value of 1 over sine 45? What is the value? How much is it? 来，按计算机。Okay, try to give me the answer. 来，文琪什么？勇气啊，勇气啊，我什么？文琪，来，我的 answer。Sub 1 over sub 2, what is 1 over, not 1 over sub 2, sub 2 over 2, 0, okay, sub 2, 1 point, is it 1.41? 是 okay, good. Okay, this 1.41, okay? Okay, this one is a similar one. Do you know what to draw or not? You want to try or not? Try to draw and see. Parallel, where will we go? Where is the focal length? Okay, online one, you want to show me the answer also can? Okay, just take the picture and send. Let me see your drawing. Everybody must draw. Everybody must try to draw. 哎，可以吗？那你，那我跟你讲哦。Okay, let me ask you a question. When it's parallel, what should you do with this line? You shall extend the line until they meet here. Can you extend or not? First line is the one parallel with the principal axis one. Okay. After that, where do you think you go? What happened to this ray? Do you know where you go or not? You should go. You'll be converging. That means you'll be passing through the focal point until they meet at where? Meet at the tip of the line. Tip. Okay. We extend two rays from the head row. It means arrowhead. This one. Okay. If you extend this line, what can you see? You meet at where? When you extend the line, you should be meeting at the focal point. You see they meet at the focal point? Focal point. What is the line when it passes through the focal point? That means you have to understand when the ray is parallel, then it will go to the focal point. When it passes through the focal point, then it become parallel again. So when it go parallel again, you meet at the arrowhead. Can you see they are meeting at the same place? This is how they form the image. Okay, no? Very easy one, just two rays. One here, one here, one here, one here. What is the third one? There's one more. Did I tell you that this line will be no deviation? No, do you not understand the meaning of no deviation? 什么是 deviation? 不懂。deviation 什么是 deviation? No deviation 什么意思？deviation deviation doesn't change direction 没有变，方向不变。English got pass or not? 谁佛啊？No deviation, undeviated, undeviated. No deviation undeviated. That means straight line. Okay, so what can we say about these three rays? They all will meet at the same point. 三个都会同时在同个点交叉的。They will meet at the same point. Okay 了 They will meet at the same point. Okay, what is the focal length? Can you see focal length is C1, F1C or CF2? Got CF2 or not? No CF2. F1C have or not? F1C have. Okay 这个明白啊 No problem, very easy. Okay, this one already found. Object move small distance away from lens, state the effect on the position and the size of the image. Away. When it's moving away, you can try to see. Let's say the new one, when you try to move it away, that means the new one, you will be still having the same size. Okay, when you move this away, based on your logic, this is this one, still go here. What happened to the second one? Second one will be from here, go here. So where is the image now? First one, go here, go back, go to the same thing. Second one from here. Can you see that the image will be here? New image. Do you understand the question? It's talking about object small distance away from lens. That means you're moving the thing further away. So now we need to see the position and the size of the image. Where is the image? Where is the position? And the size. What can you see? What is the thing that you can see? Can you tell me what you see? Diminish. Correct. It's becoming diminished. What is the second thing that you have to say? What can we say about the position? How does it move? Closer to where? It's here now. If it's moving away, means away from lens. If you go to this direction, it's away from lens. When you go this direction, closer to what? What do you call this thing? Lens. Closer to lens. Can you write closer to lens? Closer to lens. Is it correct? Closer to lens. Cheryl, you know your mistake 啊？你看你错哪里吗？啊，Cheryl，这条 this one okay. Oh, you know already. Okay. Then you should know this is passes through here. Then go here. Okay. Okay, never mind, learn from mistake. Okay, good. Good try. Uh, state the term. What do you call the name of this line? What's the name of this line? Do you know the name of this line? What is the name of this line? 这个叫什么名字？No, normal line. Okay, this is called the normal line. Use A1 to identify the triangle in the list and the correct letter for this indication. Triangle in the list and place the correct letter in the letter. Okay, incidence. That means on this ray. Okay, on this part, which one is incidence? Which one is I? N or M? M or N? N. Why N? Why not M? It must be with normal line. So incident is N. This one on this point, which one is reflection? Refraction. P or Q? P is refraction or Q is refraction? P, YP with normal line, correct? P 一定要用 normal line 量 must be reference of normal line. 看这边的 and this one. Okay. On this one, only this one, right? Which one is reflection for this one? T or S? 来问七 T or S? T 还是 S? 啊？为什么是 T? Normal line, where is normal line? 这条是 normal line 吗？ The ray with normal line, T or S? The ray 这条线跟这条线 S 不是 T 啊 ，T 这个不是 normal, must be the ray with normal line. 这个从 normal line 量过去 ，OK？ this is called, this one is not reflection. This is angle of, this is reflection. Reflection 这是反射 and what is this? 这是折射的 This is angle of refraction. This for angle of reflection. You see the difference between them? They're different. So you have to see the position. This is angle of incidence. Okay. So angle of incidence and angle of refraction P. Angle of refraction S. Is that clear? Okay. To mix up the name. 它们是不一样的东西啊。There are three different things. Okay, last part. The ray enter the glass ball, the effect, and why does it happen? So this is the ray going into the glass block. What is this phenomenon? Refraction, refraction, refraction. Why does refraction occur? This refraction of ray. Why? What happened to the speed of the ray? Change. Okay. Refraction. I think I spelled wrong. Refraction. Okay, this is a refraction of ray due to change in speed of ray due to different density. Density of medium. So basically, it's the refraction is due to the change in speed. Okay, so you make it either towards the normal or away from normal. Okay, because of the density is different. They are having the different density. Any problem? Okay, very easy this topic. Okay, sound wave. Okay, how much you know about sound wave? What is sound? Sound wave, first you need to know is a kind of longitudinal wave. What is longitudinal wave? That means the sound wave is produced by vibration. Right? You can talk because of vibration. So when you talk, your lungs, your throat, you produce a sound. Sound will make a particle to vibrate. Right? So the wave particle will be moving like that, like that, like that, like that. So sometimes you'll be moving towards one another. Sometimes it's away. Okay. So when it's towards one another, what happened to this point? It will cause high pressure. Okay. When it causes high pressure, we call it compression. It means the air being compressed. So this is the compression. Compression, compression, compression. And then in between the compression, there is another region. It's called the rarefaction, rarefaction, rarefaction. So compression to compression is one wavelength. Rarefaction is rarefaction also one wavelength. Sometimes they ask you what happened in the rarefaction. What happened here? Particle move, oscillate, or move away from each another. Then other than, it will cause what? High pressure or low pressure? Low pressure. So they will cause low pressure region and it's called the rarefaction. Okay, so basically this is all about the sound wave. Any problem? Sound wave. Okay, medium, longitudinal, and this and this. Okay, all know already. Low pressure. Okay. Okay, next one is you need to know about sound. Sound can travel through medium. Sound need what? Medium. How many type of medium? Air, water, solid line. What is the speed in the air? What is the speed of sound in the air? 330. What is the speed of sound in water? 1005. What is the speed of sound in the solid? 5000. So sometimes they'll ask you about the speed. So you need to know the speed. Speed of sound in the air, in the water, in the solid. So if you do not know, you need to go and memorize. Okay. Okay, other than that, you also need to know how to measure the sound. How do you measure the sound? Very easy. You stand here, your friend stand here. Your friend clap. So you hold a stopwatch. So when you see your friend clap the hand, you turn on, trigger on, switch on the turn on the trigger on the stopwatch. Then clap. See or trigger on. Then when you hear, then you stop stopwatch. When you see, first one is see first. Then after that you hear, then you have to stop the stopwatch. So then after that you have to measure the distance. The distance. Then you need to know the time. Distance and then plus time. Then you can measure the speed, distance over time. That's all. Okay, so measuring the thing. So this one you can go through yourself. It's all here. So go back read yourself. This one, all the definition is here. The pressure thing, vibrating, and then the low pressure is this, high pressure is compression, speed of sound in the air, 330, higher temperature, higher speed. Sound faster in the solid, in the liquid. Solid fastest, slowest in the gas. In the liquid, 1005, in the solid is 5000. Okay. Then measuring the speed between 2 points. So like that, it means one person clap, one person hold the stopwatch, measure 100 meter. Then when you see, then you have to take the time. Take the time, and then here, then you have to stop. See, start when you see, stop when you hear. Okay, start here, start see, then start. Start the stopwatch. Here, then stop. Okay, then use a different distance to do it. Okay, then measure the time. Of course, longer distance, longer time. Then take 3 time, take average. Then after that, use a formula, distance over time to measure the speed. Okay, then you have to use oscilloscope. Measure the sound by oscilloscope. So when you clap here, then when the sound you'll be heard by the first microscope. When the microscope detect the sound, you show a pulse. What is pulse? Like that, pulse. When you hear again, another pulse. So first and second. So between first and second, there's a time. And then there's a distance. So same thing. Speed will be distance over time. That's all. This is starting time. This is the stop time. Clap. Go here. Another pulse. Pulses. Okay. Detecting the microwave. Microwave can detect sound. That's why you can sing through the microphone. Okay. So microphone not just for singing. Microphone also can use to detect the speed of to measure the speed of the sound. Okay. Okay, so set up trigger on. So you trigger on when you detect the first sound. Then you trigger another one more time. Then adjust until the both microphone can be seen on the screen. Repeat with different distance. That's all. Then take average. Then take the time. Okay. So same formula. Average is a distance over time. Okay. So all about the practical thing. This one also. Okay. Next one important thing is about the pitch and loudness. What is pitch? Pitch related to frequency. Frequency. Do you know what is frequency? 1 over period. What is the definition for frequency? N over T. What is N? F is equal to N over T. N is what? Number of what? Oscillation. Oscillation. And then T is a time taken. Time. So if the frequency is very, very high, you see more wave. It means there'll be many this kind of thing. If the frequency decreases, you see less wave. Yeah, 问七什么事？Yeah. 大家讲，泄漏考题，泄漏考题啊。Okay, so this is the more wave of higher frequency, more wave. Lower frequency, less wave. This is wave. Okay, cannot. So pitch, high pitch means high frequency. Low pitch means low frequency. Second thing is the loudness. What is loudness? How loud? Loudness related to what? Amplitude. So when you compare the sound, one like that, the other one like that, this amplitude is smaller, this amplitude is larger. Larger amplitude, louder. Smaller amplitude, softer. Soft sound, low amplitude. Loud sound, bigger amplitude. Okay or not? Okay. So basically you learn about the thing. This one, high pitch means high frequency, low pitch means low frequency. Amplitude, volume. Larger amplitude, larger volume. Lower amplitude, lower volume. Okay. Another way of the detector the sound is using the concept of echo. What is echo? 回音 echo 回音. That means when you shouting, you stand here and shout to the cave. You can't 望着山洞喊. So the sound will become and then go back, reflected. So this is cave, 山洞 cave. This is a reflection of sound. So that means the sound will be traveling double the distance. You go by d, coming back also by d. So speed of the wave will be distance travel over the time. For echo, you will travel double the distance over the time. So the experiment will be when you clap, the sound wave will be coming here, hit the wall, and then reflected back. So that means when you hear the sound, okay, so that means the formula, the V is 2D over T. So Vt is 2D. D will be Vt over 2. So there's a formula here. Can you see that the formula? The distance is half speed times time. Speed times time divided by 2. So this is a distance. Okay? Distance of this echo thing. Okay. Okay. Okay, the next thing that you need to know is called the ultra. So sound wave 20 to 20 kilo hertz is our hearing range. Normal hearing range. This is a thing that we can hear. Anything between this and this, we can hear. Below this, cannot hear. Below, what is the name of this below? It's called infrasound. Below 20, infrasound. Above 20 kilo, ultrasound. So this ultrasound is very important. Why? Because ultrasound is for medical diagnosis. For what? Because the doctor want to see whether the baby is moving or not, is growing up or not. If one day the baby, when you see the ultrasound, the size doesn't change after 1 month, still after 3 weeks or 2 weeks, initially is 15 cm. After 1 week, still 15 cm. What happened? Maybe baby wrong, something wrong. Maybe baby already died. So need to do the abortion, go to do surgery, take out the baby. So if you see the baby is becoming bigger and bigger, then the mother will be very happy. Okay, then this is the ultrasound. Okay, human range 2020, ultrasound more than 20 kilo. Okay, less than 20 infrasound. Ultrasound, medical scanning of tissue, non-destructive. So one is for this. This is for baby. Okay. First one is for the measuring the speed of sound boundary reflected, transmitted, emitted, receiver. Display on this time taken will tell you about the speed of the ultrasound in the material. Okay, it means this way. This is the stomach. Inside maybe got something here. So ultrasound, put it here. When you send the ultrasound here, this is called transmitter. So when it hit on the hard surface, it will be reflected back. So this is receiver. So here to here is a tap. Okay. So then they will tell many things. So on here, on the CRO, you see pulses like that. Okay. So this one will tell you about the time. Okay. So because the speed is 2D over T, so the depth will be Vt over 2. So this one will tell us about the depth. We use this way to measure the depth of something. So ultrasound reach a boundary, transmitted, receiving, and transmitted means going in, receive means you can receive. So play on this screen. So from the boundary, we can determine the time. So this is the time from the CRO. And then the speed, we can use this to measure the speed. So this one all same concept. That means, let's say you have a boat or ship for it to become a fishing boat. Okay, so we want to know whether downwards got fish or not. So how do we check? It means we have to send a wave downwards, and then we need to measure how long we can get back the signal. If it take a long time to return, that means the water is very deep. There's nothing down there. If let's say the time return is very short, that means the ultrasound already hit something, then reflected back. That means downward got fish. Then you can start to release the net, the fishing, what do you call that? 渔网叫嘛? Fishing net to catch a fish. Okay. Okay, fishing net. Okay, so this is the thing. Another one is we want to see whether there's a crack or not. Metal bar. If inside got crack, what happened? If got crack line, we cannot use. We have to replace with a new one. How do we know whether inside there's a crack or not? So we have to see the ultrasound. Because when ultrasound go in, ultrasound will be reflected. So from the way it reflect, you can tell whether there is a crack or not. So got crack, then you have to change a new one. So if it has a crack, that means the wave will take a shorter time to return. If no crack, then it take a longer time. Okay. This one not so important. Just tell you that got crack or no crack. Okay. Ultrasound is important for medicine. If you want to know whether baby is healthy or not healthy, if you know ultrasound, very difficult. We cannot see inside. We can only see when you open up the stomach. Then only can see. If the mother is okay, baby is okay, should you go and do operation or not? Cannot, no. So you need to find out a way to know whether the baby is healthy or not healthy by using ultrasound. That's why ultrasound is important. Okay. So ultrasound, normally the doctor will apply a layer of gel. So you need to apply a gel first. When you put a gel, then the signal can go in. The signal also can come out. So this is ultrasound. So pulses emitted, pulses received, ultrasound, detect the depth. So the depth, you can see the size of the baby. The distance is double because B is 2D over T. Signal double because signal come in and go back, you travel double the distance. Okay, that's why double signal. Bounce off at the bottom and then reflect back. Okay, so this is how we detect Okay, I think the exercise we'll do it next week. Okay, any question before I end the lesson? Uh, don't forget to bring back the lesson, the worksheet. Okay, see you next week. Bye. 哎，文献你们学校建脚哪里啊？